Hello everyone, welcome to King's Education Channel. My name is Sean and I am using YouTube as a platform to go through past year examination questions for P6 Math. While there's no promises, I will try my best to upload one video every week. So moving along a bit about myself, I'm currently an undergraduate at NUS, which is the National University of Singapore. And I am a chemistry major with a minor in aquatic ecology. So a bit more about me is that I've been teaching privately for several years now, and normally I've been teaching P6 Math, Secondary 4 Math, and P6 Science. And some of my hobbies include listening to Korean music and keeping fishes. Today, I'll be sharing about some of the ways I approach problem sums, which is many students fear, as well as the number one tip to helping students solve questions fast. Okay, moving on. So the first tip is that I feel that many students, they are not very familiar with numbers. So for example, let's say I have a square here. I tell you that the area is 144 cm square. Through my many years of teaching, right, I feel that many students, when they see numbers like 144, they are unable to recognize that it's actually a square number. And this is actually quite important because being familiar with numbers and being sensitive to numbers, it helps a student realize how to solve the questions and the problem sums. And so for moving on to this, so 144 is actually a square number, which is 12 times 12. So one way to approach this and improve your sensitivity to numbers is through learning of the multiplication table. So it's very important to be very familiar with the multiplication table. So how do I normally approach learning the multiplication table? So you can go from 1 times 2 equals to 2, 1 times 3 equals to 3, so on and so forth, normally until 1 times 10 equals to 10. So I'll do this for numbers all the way until 10. So 10 times 1, 10, 10 times 2, 20, so on and so forth. So 10 times 10 equals to 100. So normally I think outside schools will normally teach until here, which is 100 when students are still young. But there are a few numbers which I feel is important to know beyond 100. So for example, I feel it's very important to know what's 11 times 11, which is 121, 12 times 12, which is 144, 13 times 13, which is 169, 14 times 14 equals to 196, 15 times 15 equals to 225, so and so forth. As well as going up, this is square numbers. Sometimes I think cube numbers are also equally helpful for students, especially if they want to solve problem sums fast. So for example, what is 729? 729 is actually 9 times 9 times 9. So these are some of the numbers which I feel are quite important. So there are still more examples for the cube numbers, and I think if students can regularly go and memorize these multiplication tables, I think over time they'll be more sensitive to these numbers, and this will help them to solve problem sums at a faster pace. Yes. Okay, moving on to the methods I use for solving questions. So when I solve questions, I normally use these are the few methods that I normally use. So the methods I use are normally algebra, but this not really common. It's only for those extremely hard questions. Probably I'll use it in maybe a few of the prelim papers by some of the top schools which are really hard lah. If not regularly, I don't really use algebra to approach problem sums. The most common method which I use to solve problem sums is models, because using models it helps students to visualize better with the question, and if they read the question properly and if the right models are being drawn, it will really help them understand the question fully, and this will help them solve the problem sums easily. And lastly, although I don't really advocate the use of this method, but sometimes if there's no choice, I feel that guess and check isn't as bad as you think. So you can try guess and check. No, this guess and check method is normally for questions like there's a farm, there's cows, chickens, ducks. So total they tell you how many legs are there, so and so forth, and they ask you to guess like how many chicken are there. Yeah, so for this type of questions, unless the school have taught the students how to use the elimination method, otherwise I would just ask my students to use guess and check. Although guess and check may be quite time consuming, but I believe that if students are very fast with numbers, I think it will be quite it won't take very long for them to find the answer in the end. Yeah. And if you think that guess and check isn't that good because maybe guess wrongly or so and so forth, then in the end the answer is wrong. But actually, after guessing, you can test if your guess is correct. So if the students after they guess, if they do a proper check on the answers, actually guess and check can also get them the correct answers. Okay, moving on. Today I'll be going through two questions. So two problem sums to demonstrate how I normally use models. Sometimes the models that I use, I don't really draw them out like boxes. Some places they teach you how to draw boxes and stuff, so I don't normally do that. Okay, let me make sure that the question, you can see the question. Yeah. Okay, so looking at question 1, Wayne and Su-Ling shared some money in the ratio of 3:5:12. After Su-Ling spent 25% of her money and Annie spent 2/3 of hers, Su-Ling found that she had $72 more than Annie. What was the sum of money they shared? Okay, so when I do questions, I normally ask students to go through the questions line by line. So for the first line, Annie, Wayne, and Su-Ling shared some money in the ratio of 3:5:12. So I will just write Annie as A, Wayne as W, and Su-Ling as S. So it will be in a ratio of 3:5:12. So for ratio, right, 3:5:12, you can take it as units. So I can say that Annie have 3 units, Wayne have 5 units, and Su-Ling have 12 units. Okay, moving on to the next line. After Su-Ling spent 25% of her money and Annie spent 2/3 of hers. So here I have one that is in percentage and the other one is in fraction. So normally I ask students to change them to the same type. So it's either you change everything to percentage or everything you change to fraction. So for me, I personally like to use fraction. So 25% is actually 1/4. Okay, so Sulin actually spent 1/4 of her money, Annie spent 2/3 of her money. Then at the end, Sulin found that she has $72 more than Annie. So here the ratio you see here is actually before. And now I will do the ratio for after. So Annie, Wayne, and Sulin. So through this process, Wayne didn't change, so his units will still be 5. But what changed is Annie's and Sulin's unit. So Sulin spent 1/4 of her money, so Sulin have 12 units, and times 1/4, you get 3 units. So she spent 3 units. So in the end, she should have 9 units. Sorry, it's here. And Annie spent 2/3 of her money, so she have 3 units. So 2/3 of her 3 units is 2 units. And after she spent 2 units, she get 1 unit. So the final ratio should be 1:5:9. And they say that Sulin have $72 more than Annie. So Sulin here is 9 units, while Annie here is 1 unit. So using this, we know that Sulin have 8 units more than Annie. So these 8 units represent $72, and 1 unit is equals to $72 divided by 8, which is $9. So now we know $9 is equals to 1 unit. So the question wants to find out what was the sum of money that they shared. So using this, at the start they have 3 units plus 5 units plus 12 units. Total is 20 units. So with 20 units, it will come out to $180. So at the start, they had $118 in total, which is the sum of money which they share. Okay, let's move on. The next and the last question for today. So the amount of money Sally had to the amount of money Ray had was 4:5. After Ray gave Sally some money, Sally had twice as much money as Roy. I say wrongly, it's Roy. Find the amount of money Roy gave Sally if Sally had $180 at first. So the amount of money Sally had to the amount of money Roy had was 4:5. So you can write before, S to represent Sally, R to represent Roy. So it is 4:5. And after Roy gave Sally some money, Sally had twice as much money as Roy. So there's some change right over here. So there's an after, Sally is to Roy. So through this process, you need to, sometimes in questions, you need to ask yourself, what is the thing that did not really change in the question? And this is the question I normally ask my students every time when they are solving problem sums. For example, in this question, you should know that actually when Roy gave Sally some money, the total amount of money that both of them have did not change. So moving on, so here I got total of 9 units. And after Roy gave Sally some money, Sally have twice as much money as Roy. So the ratio should be 2:1. But then 2:1 is in total is only 3 units. But in fact they should still have 9 units. So you should times 3. So this should be 6:3. So Sally should have 6 units, Roy should have 3 units at the end. So find the amount of money Roy gave Sally if Sally have $180 at first. So this $180 is equals to the 4 units, and 1 unit is equals to $180 divided by 4, which is $45. So now that we found out that 1 unit is $45, the question asks you for the amount of money that Roy gave Sally. So at first Sally had 4 units, at the end Sally has 6 units, so she gained 2 units. Whereas for Roy, he had 5 units, then he gave away 2 units, then he became 3 units. So in this, through the process, actually Roy gave Sally 2 units, which is what you are trying to find. So in the end, the answer should be 2 units equals to $45 times 2, which is $90, and that's the answer you are finding. Yeah. Okay, that's it for today. I hope you learned something, and do comment down in the comment box below to let me know what you would like to see more in future. And if you like the content that I'm creating, please do like, share and subscribe to my channel. Thank you, and see you next time.